Somewhere right now, water is moving through the middle of South America, slow and wide and patient, the way it has moved for millions of years. Tonight, we are going to follow that water. Not quickly, not with any urgency at all. We are simply going to trace its path from the high, cold rock of the Andes Mountains down through the warm, green heart of a continent and out into the Atlantic Ocean, thousands of miles away. There is no need to remember anything. There is no test at the end. You can simply let this story move through you the way the river moves through the land. And if you fall asleep before we reach the ocean, the river will still be there tomorrow, still flowing the way it always has. Long before there was an Amazon River as we know it today, there was a very different landscape in South America. This was tens of millions of years ago, back when the continent was still settling into the shape it would eventually hold. At that time, geologists believe the great river system that would one day become the Amazon did not flow eastward toward the Atlantic Ocean at all. It flowed the other way, westward, toward what is now the Pacific side of the continent. The land was different then. South America and Africa had already drifted apart, slowly, over unimaginable stretches of time. But the Andes Mountains, which now form the western wall of the continent, had not yet risen to their full height. Without that wall of rock, water simply followed the gentle downward slope of the land, and the gentle downward slope, at that time, pointed west. This is worth sitting with for a moment, quietly. The river that carries more water than any other river on earth, the river whose name is now inseparable from the idea of a vast, breathing rainforest, once moved in the opposite direction. Rivers are not permanent arrows. They are temporary agreements between water and land, and when the land changes, the water changes with it. The land did change. Deep beneath the surface of the earth, enormous plates of rock were pressing against one another, the way they still do today, at a pace far too slow for any of us to feel. The Nazca Plate, out beneath the Pacific Ocean, was pushing eastward and sliding underneath the South American Plate, in a process geologists call subduction. This slow collision, continuing for tens of millions of years, began to lift the western edge of South America upward. Layer by layer, inch by inch, the Andes Mountains rose. They did not appear suddenly. There was no single dramatic moment. It was simply pressure, applied steadily, for a span of time so long that entire species of plants and animals rose and disappeared before the mountains reached anything close to their current height. As the Andes grew taller, they began to change everything downstream. A mountain range that tall does more than block a view. It reshapes the flow of air and water across an entire continent. The rising Andes formed a barrier that the westward flowing rivers could no longer cross. Slowly, the water that had once found its way to the Pacific began to pool instead, forming what scientists now believe was a vast, shallow interior. Some researchers describe this ancient landscape as a wetland system, others as a series of large lakes, and there is still ongoing scientific discussion about exactly what this middle period looked like, whether it was closer to a marsh, a lake, or something in between, changing over millions of years. We will simply say that the water was there, held in place by the new mountains to the west, with nowhere yet to go. It is worth remembering that all of this took an extraordinary amount of time, more time than is easy to picture. If you imagine the entire history of the Andes rising and the Amazon basin forming as a single day, then everything we have described so far might occupy the quiet hours of early morning, long before anything we would recognize as a river existed. There is no rush in geology. Mountains do not hurry. Rivers do not hurry. And so tonight, we are not going to hurry either. Eventually, the pooled water in this vast interior basin found a way out. Because the Andes blocked the path to the Pacific, and because the land to the east sloped gently down toward the Atlantic Ocean, the water began, very gradually, to drain eastward instead. This was the beginning of the river system we now call the Amazon. It did not happen all at once. It happened the way most large changes in nature happen, as a slow accumulation of small shifts, until one day, if anyone had been there to notice, the general direction of the water had reversed entirely. Scientists studying this reversal look at many different kinds of evidence to understand when and how it happened. They study the sediment layers preserved in rock, which record, like pages in a very slow book, what kind of environment existed in a particular place at a particular time. They study the minerals carried in ancient river sand, because different source rocks leave different chemical signatures. And by tracing those signatures, researchers can tell whether a grain of sand traveled from the Andes or from somewhere else entirely. They study the fossils of fish and other aquatic life, because some species could only have lived in a river flowing in one direction, connected to one particular body of water. All of this evidence, gathered slowly over decades of careful fieldwork, points toward a river that changed its direction sometime in the middle of what geologists call the Miocene epoch, a span of time roughly 11 to 10 million years ago, though the exact timing remains an area of continued research and gentle scientific disagreement. Once the river began flowing eastward, it started doing what rivers do everywhere, cutting into the land, carrying sediment, depositing that sediment elsewhere, building the physical shape of the basin around itself. But because this particular river was draining an enormous mountain range on one side and moving across a vast, low, tropical landscape on the other, the scale of what it built was unlike anything else on the planet. Over the following millions of years, the river carried down not just water, but enormous quantities of rock and mineral sediment, ground down by ice and rain high in the Andes, and it deposited that sediment across the lowland basin, layer after layer, year after year, century after century. This is, in a sense, how a continent gets rearranged without anyone planning it. No single storm or flood accomplished this. It was simply water doing the same patient work over and over for a length of time that makes a human lifetime seem impossibly small. And with each layer of sediment, the basin took on more of its modern character. The flat, low, fertile land that would eventually support the largest rainforest on Earth. As we move slowly through the coming segments of this story, we will follow the river's continued shaping of the land, the way its water carved out the modern channel we recognize today, the way it built the world's largest river basin, the way it created the conditions for a forest so vast it generates its own weather. But for now, in this first quiet stretch of the story, it is enough to simply hold this image. A young mountain range rising in the west, a great pool of ancient water finding a new direction to flow, and a river beginning its long eastward journey toward an ocean that, at the time, did not yet look the way it looks today either. The Atlantic Ocean itself was still widening during this period, still slowly separating South America from Africa, the two continents drifting apart by a distance of only a few centimeters each year, roughly the speed at which a fingernail grows. It is strange to think that the same slow, patient forces that grew the mountains also, in their own way, opened the ocean that the river would eventually reach. Everything in this story moves at the pace of deep time, unhurried, indifferent to human clocks, simply continuing. If you are still awake, there is no need to hold on to any particular fact from what we have covered so far. The mountains rose, the water pooled, the water found a new path. The river began to flow toward the Atlantic instead of the Pacific. That is the whole of it, and it is enough. In the next part of our journey, we will follow the water as it moves down from the high, cold peaks of the Andes, through cloud forest and foothill, and out into the wide, warm lowlands, where the real work of shaping a continent continues. Rest now if you need to. The river is not going anywhere. It has been flowing quietly for millions of years, and it will still be flowing long after tonight. If you are joining us partway through, or if you drifted off during the last part of our story, that is perfectly all right. We left the river at the moment it began flowing eastward, down from the newly risen Andes Mountains toward a widening Atlantic Ocean. Tonight, or rather, in this next quiet stretch of the story, we will follow that water more closely from the place where it is born, high in the mountains, down to the place where it begins to spread out across the lowlands. High in the Andes, in southern Peru, there are small streams that most people will never see. They begin as glacial melt and mountain rainfall, at elevations so high that the air is thin, and the nights are cold, even near the equator. One of these streams, on the slopes of a mountain called Nevado Mismai, has long been considered by many geographers to be among the most distant sources of the Amazon River, though it should be said gently that identifying a single, definitive source for a river This complex is not a simple matter, and different researchers, using different methods, have proposed different candidate sources over the years. What matters more than the exact coordinates is the general picture. Cold, clear water, beginning its journey at an elevation of more than 5,000 meters above sea level, in air thin enough to make breathing difficult for an unacclimated visitor. From these high beginnings, the water moves downward, the way water always does, obeying gravity in the simplest and most patient way possible. It gathers into small streams, and the streams gather into larger streams, and gradually, as it descends through the folded valleys of the Andes, the water takes on names that will be unfamiliar to most listeners outside of Peru. The Apurimac, the Ucayali, the Marañón. Each of these is already a substantial river in its own right, carving through steep canyon walls, moving quickly over rocky beds, carrying with it the fine sediment that gives Andean rivers their characteristic pale, milky color, a color that comes from suspended particles of ground rock, worn away from the mountains themselves. This sediment matters a great deal to the story we are telling, so it is worth pausing here gently to consider it. As rain falls in the high Andes, and as glaciers slowly melt, the moving water grinds against exposed rock, wearing it down into fine particles. This is simply physics, the same physics that shapes canyons and smooths river stones anywhere in the world. But in the Andes, the process is unusually vigorous, because the mountains are young, geologically speaking, and still rising, and because the slopes are steep, and because the rainfall in parts of this region is heavy. All of this combines to produce rivers that carry an extraordinary quantity of sediment down out of the mountains and into the lowlands below. As the rivers descend from the high Andes, they pass through a landscape that changes gradually, the way most natural landscapes do, without sharp boundaries. The bare rock and thin, cold air of the high peaks give way, over the course of a descent that can take a traveler through several thousand meters of elevation change, to cloud forest, a strange and beautiful environment where clouds settle permanently against the mountainside, keeping the vegetation constantly damp. Ferns grow here in great abundance, along with mosses and orchids, in a kind of soft, cool green that is quite different from the greens we associate with the lowland rainforest still further ahead. Continuing downward, the cloud forest gradually gives way to what botanists sometimes call montane forest, and then, lower still, to the foothill forests that mark the transition into the true Amazon lowlands. By the time the water reaches these lower elevations, it has already dropped nearly all the way from the roof of the continent to a landscape that, from this point forward, is remarkably flat. This is an important detail, and one worth sitting with quietly for a moment. The Amazon basin, once you are past the Andean foothills, has an extraordinarily gentle slope. Over a distance of many hundreds of kilometers, moving from west to east, the land descends only a very small number of meters. This gentle, almost imperceptible gradient is one of the central reasons the Amazon behaves the way it does, why it moves the way it does, why it floods the way it does, and why it has shaped the land the way it has over the millions of years since it began flowing in this direction. A steep river moves quickly, cuts a narrow channel, and carries its sediment a long way before depositing it. A gentle river, moving across a nearly flat landscape, behaves quite differently. It slows down, it spreads out, it wanders, forming wide loops called meanders, doubling back on itself, sometimes cutting through the neck of its own loop, and leaving behind a curved, isolated lake called an oxbow lake. Over the seasons, and especially during the rainy months, a gentle river across flat land also tends to overflow its banks, spreading water and sediment across an enormous surrounding floodplain. All of this is exactly what happens along much of the Amazon's length once it leaves the Andean foothills and enters the lowland basin. The water that began as cold, clear mountain streams has, by this point, become something else entirely. A warm, sediment-laden river, moving slowly across a vast, low landscape, feeding an enormous network of smaller rivers, streams, and seasonal channels that spread outward across the basin like the branches of a tree lying on its side. Some of these tributaries, rivers that flow into the main Amazon channel, are so large that if they existed on any other continent, they would themselves be counted among the great rivers of the world. The Madeira, the Negro, the Xingu, the Tapajos. Each one drains its own portion of the basin, carrying its own particular color of water, shaped by its own particular geology, before joining the main river on its long path to the Atlantic. It is worth noting gently that not all of these tributaries look alike, even though they are part of the same larger system. Rivers draining areas of younger, sediment-rich Andean rock, like the main stem of the Amazon itself, tend to run pale and cloudy, sometimes described as café con leche in color, coffee with milk. Rivers draining older, more stable, sandy soils, like the Rio Negro, run dark, almost black, the color coming from decomposed plant material dissolved in the water, in much the same way that steeped tea takes on a dark color from tea leaves. And rivers draining certain crystalline bedrock regions run a clearer blue-green, carrying very little sediment at all. When these different rivers meet, their waters do not blend immediately. For a distance of several kilometers, sometimes more, two rivers of different colors can be seen flowing side by side within the same channel, a pale current and a dark current, moving together, but not yet mixed, before gradually, gently becoming one. This meeting of waters happens at several points along the Amazon system, and it offers a quiet, visual reminder of just how many different sources feed into this single river. Water that fell as rain in the Andes, water that seeped up from ancient sandy soils in the heart of the basin, water that has been circulating through the forest canopy itself for who knows how many cycles of evaporation and rainfall. All of it eventually joins the same slow, wide, patient current, moving steadily toward the Atlantic Ocean, still many hundreds of kilometers away. We will follow that current further in the next part of our story, as it moves into the true lowland basin and begins the work of shaping the forest around it, flooding certain lands in certain seasons, building natural levees, carving and abandoning channels over the centuries. For now, it is enough to picture the beginning of this journey. Cold water high on a mountainside, gathering slowly into streams, descending through cloud forest and foothill, arriving at last on the flat, warm lowlands, ready to begin the long, unhurried crossing of an entire continent. We continue now, slowly, following the river as it leaves the Andean foothills behind and enters the wide, flat expanse of the Amazon lowlands. This is where the river truly begins to spread out, and where the shaping of the land, the actual physical rearrangement of a continent, becomes easiest to see. Once the water reaches the lowland basin, it is moving across land so gently sloped that engineers who have measured it describe the gradient in terms that are difficult to picture without comparison. In much of the middle and lower basin, the land drops by only a few centimeters for every kilometer traveled. Water moving across a slope this gentle does not rush. It cannot rush. It simply spreads, the way a small amount of liquid spilled onto a nearly flat table will spread outward in a slow, wide sheet, rather than run quickly in a narrow stream. This single fact, the extraordinary flatness of the Amazon basin, explains a great deal of what follows in our story. Because the river moves so slowly across such flat ground, it does not stay within a single fixed channel. Instead, over the centuries, it wanders. It curves. It doubles back on itself in wide loops called meanders, the same kind of looping shape you might notice in a slow stream of water on a flat sidewalk after rain. Except here, the loops can span kilometers rather than centimeters. As the river erodes the outer edge of each curve and deposits sediment along the inner edge, the loop grows wider and wider over time, sometimes becoming so pronounced that the river eventually cuts directly across the narrow neck of land, separating one side of the loop from the other. When this happens, the river takes the new, shorter path, and the old looping channel is left behind, cut off from the main flow, forming a curved lake known as an oxbow lake. If you were to look down at the Amazon basin from above, particularly along certain stretches of its middle course, you would see dozens, even hundreds, of these curved, crescent-shaped lakes scattered across the landscape, some connected to the main river during high water, some isolated year-round. Each one is a kind of quiet historical record, a place where the river used to flow before it changed its course and moved on. The river does not erase its own history. It simply leaves it behind in the shape of the land itself for anyone patient enough to look. This constant, slow wandering of the river channel is part of what has allowed the Amazon to build such an enormous floodplain over millions of years. As the river shifts its course, it deposits sediment across a wide band of land on either side of its current channel. And then, decades or centuries later, it may shift again, depositing new sediment somewhere slightly different. Over a long enough span of time, this process builds up a broad, fertile, gently undulating floodplain that can stretch for many kilometers on either side of the river's current path. Geologists sometimes refer to this floodplain, in Portuguese, as várzea, meaning simply lowland or floodplain, and we will return to this term later in our story when we speak about the particular kind of forest that grows there. The floodplain is not static, even today. Each year, as the seasons shift between wetter and drier periods across different parts of the vast basin, the water level in the Amazon and its tributaries rises and falls by a remarkable amount. In some stretches of the river, the difference between the lowest water level of the dry season and the highest water level of the wet season can exceed 10 meters, and in a few particularly dramatic locations, considerably more than that. This means that land which stands well above the water's edge in one part of the year may be entirely submerged, sometimes many meters deep, a few months later. Trees that grow in this floodplain forest have adapted to this rhythm over an immense span of evolutionary time, developing tolerance for months of standing water around their roots and trunks. Something most trees elsewhere in the world could never survive. As the river continues eastward, it is also, slowly and continuously, redistributing an enormous quantity of sediment across the whole of the basin and beyond. Scientists studying the sediment load of the Amazon have estimated that the river carries an extraordinary volume of suspended material toward the Atlantic Ocean each year. Sediment that originated, in large part, from the erosion of the Andes Mountains, thousands of kilometers upstream. This sediment does not simply vanish once it reaches the ocean. A significant portion of it settles along the coastline of northern South America, contributing to the growth of coastal mudflats and mangrove systems that extend for hundreds of kilometers along the shore. Some of it carried by ocean currents even further north, along the coast of what is now French Guiana and beyond. In this way, the Amazon River has, quite literally, been building new land for millions of years, moving material from the young, rising mountains in the west to the low coastal margins in the east, a process that continues at this very moment, unnoticed by almost everyone, as it always has. If you consider the entire span of time since the river reversed its direction and began flowing toward the Atlantic, the sheer quantity of rock and soil that has been moved from one part of the continent to another is difficult to comprehend in ordinary terms. It is, in its own slow way, one of the largest engineering projects in the natural world, carried out with no plan, no blueprint, no deadline. Simply the patient, repeated action of moving water. The basin itself, shaped by all of this sediment and all of this wandering, slow-moving water, has become the largest river basin on the planet, draining an area that includes not only the majority of Brazil, but also large portions of Peru, Colombia, Bolivia, Ecuador, Venezuela, Guyana, Suriname, and French Guiana. Water that falls as rain nearly anywhere across this enormous stretch of the continent will, eventually, if it does not evaporate first, find its way into some tributary of the Amazon, and from there, into the main channel, and from there, eventually, slowly, out into the Atlantic Ocean. It is worth pausing here, in the quiet middle of this story, simply to picture the scale of what we are describing. A basin covering roughly 7 million square kilometers. A river carrying, at its mouth, a far greater volume of fresh water than any other river system on Earth, more than the next several largest rivers combined. A floodplain forest adapted to rise and fall with the seasons, year after year, for longer than human beings have existed as a species. None of this happened quickly. None of it happened with any drama or sudden event. It happened the way a river always shapes a landscape, through the accumulation of countless small, unremarkable moments, repeated across a span of time so long that it is, frankly, easier to feel than to fully understand. In the segment that follows, we will slow down even further and look closely at the forest itself. The way the river's seasonal rise and fall has shaped an entire ecosystem, and the particular kinds of trees and roots and creatures that have learned to live with water that comes and goes, year after year, in a rhythm as old as the river itself. For now, simply picture the water, wide and slow and pale with sediment, moving across a nearly flat land, curving gently first one way and then another, leaving behind quiet crescent lakes as it goes, building, without hurry, the very ground beneath it. We return now to the floodplain, the wide band of low, fertile land that borders much of the Amazon River and its larger tributaries, the land we began to describe in the previous part of our story. Here, in this next quiet stretch, we will look closely at the forest itself and at the particular way it has adapted over an immense span of time to a rhythm of flooding and retreat that repeats every single year. Across much of the Amazon basin, the year divides broadly into a wetter season and a drier season, though the exact timing differs depending on where in the basin you happen to be standing. Since the basin is so large that weather patterns in the north do not always match those in the south. During the wetter months, heavy and frequent rainfall, combined with the melting of snow and ice high in the Andes, sends an enormous volume of additional water down into the rivers of the basin. The rivers respond by rising, slowly at first, then more steadily, until the water begins to spill beyond its usual channel and spread out across the surrounding floodplain. In the areas closest to the whitewater rivers, the pale, sediment-rich rivers whose origins trace back to the Andes. This seasonal flooding creates a particular kind of forest known as varzea. Varzea forest floods with water that carries a great deal of suspended sediment. And as that sediment settles onto the forest floor during the flood season, it deposits a fresh layer of nutrient-rich soil year after year, in much the same way that the annual flooding of the Nile once renewed the farmland of ancient Egypt. This makes varzea soil unusually fertile compared to much of the rest of the Amazon basin, where, perhaps surprisingly to some listeners, the soil underlying the forest is often quite poor in nutrients, with most of the ecosystem's nutrients held not in the ground, but in the living plants and decomposing matter above it. In other parts of the basin, particularly along the Blackwater rivers, whose dark, tea-colored water carries very little sediment, a different kind of flooded forest occurs, known as agapo. Because Blackwater rivers carry so little sediment, the annual flooding in agapo forest does not renew the soil in the same way that varzea flooding does. Agapo soils tend to remain sandy and nutrient poor, and the plants growing here have adapted over a very long span of evolutionary time to survive with fewer available nutrients, while also tolerating months of standing, darkly stained water around their roots each year. In both of these flooded forest types, the trees themselves have developed remarkable adaptations to survive a season of near total submersion. Some species have evolved trunks capable of tolerating months without direct access to open air around their root systems, essentially entering a kind of dormant state during the flood period, much the way a temperate tree might become dormant during a cold winter, except here, the dormancy is triggered by water rather than by cold. Other species have adapted their reproductive timing to match the flood cycle precisely, releasing seeds or fruit at the moment the water is highest, so that the fruit can float, sometimes carried a considerable distance from the parent tree before eventually settling into the mud as the water recedes. This timing has, in turn, shaped the behavior of the animals that live in and around these flooded forests. A great many fish species found in the Amazon basin have adapted their own life cycles around the flood season, moving directly into the flooded forest itself once the water rises high enough, swimming between the trunks of submerged trees in search of fruit and seeds that have fallen or been carried into the water. Some of these fish species are surprisingly effective seed dispersers, carrying seeds away in their digestive systems and depositing them, undamaged, in an entirely new part of the floodplain once they eventually pass through. In this way, the fish and the trees have developed a kind of quiet, long-standing partnership, each depending on the other's seasonal rhythm, a partnership that took shape gradually over millions of years, without either party, in any sense we would recognize, planning it. Among the fish that make use of the flooded forest is the tambaqui, a large, deep-bodied fish capable of eating fruit and seeds that fall from the canopy above. Its teeth, adapted specifically for cracking open the hard shells of certain seeds and nuts. There are also smaller species that specialize in different kinds of fruit, different heights of flooding, different stretches of forest, so that across the full extent of the flooded Amazon, an enormous diversity of fish has developed, each species occupying its own particular niche within the same general, water-driven rhythm. Above the waterline, in the branches of the flooded forest, other creatures make their own use of the seasonal rise and fall. Certain species of monkey move more freely through the canopy during the flood season, when the water below makes ground-level travel impossible for many animals, effectively turning the upper forest into the only viable pathway for a period of several months each year. Birds nest according to their own calendar, timed to avoid the highest water and to take advantage of the abundance of insects and fruit that the flood season brings. Even the insects themselves, in their staggering diversity throughout the Amazon basin, have species adapted specifically to the flooded forest environment, some completing entire life cycles that depend on the presence of standing water for only part of the year. It is worth noting gently that this seasonal flooding pattern does not affect the entire Amazon basin equally. Away from the rivers and their immediate floodplains, across the much larger area of what is sometimes called terra firm forest, meaning firm ground, the land does not flood at all, even during the wettest months. Terra firm forest, which makes up the majority of the Amazon's total forest area, is a different ecosystem altogether, with different soil conditions, different tree species, and a different community of animals, many of which never encounter standing floodwater in their entire lives. The contrast between the flooded Varzea and Agapo forests, close to the rivers, and the vast unflooded terra firm forest, further from the water, is one of the fundamental patterns that organizes life across the entire Amazon basin. A pattern set in motion, ultimately, by the same gentle slope of land and pattern of rainfall we described earlier in our story. Taken together, these different forest types, flooded and unflooded, fertile and nutrient poor, form a landscape of extraordinary variety, all of it shaped, directly or indirectly, by the presence and behavior of the river system running through it. The river does not simply pass through the forest. In a very real sense, over millions of years, the river has helped to determine which forest grows where, which trees have adapted which strategies, which fish and birds and mammals have found which particular way of making a living within this vast green world. As we move forward in our story, we will begin to turn our attention toward the people who have lived alongside this river and this forest for a very long time, learning to read its seasonal rhythms just as closely as the fish and the trees have. But for now, it is enough to simply picture the forest breathing with the water, rising and falling each year in a rhythm as steady and unhurried as the river itself. Fruit dropping into still, dark water, fish moving quietly between submerged trunks, and the whole vast system continuing, season after season, the way it has for longer than anyone can easily imagine. We turn now, gently, from the forest and the water to the people who first made their lives alongside them. This part of the story moves more slowly than the others, not because there is less to say, but because it deserves a calm and careful telling. Human beings have lived in the Amazon basin for a very long time, considerably longer than was once assumed by many outside researchers. Archaeological evidence gathered over the past several decades suggests that people first arrived in South America and eventually in the Amazon basin itself more than 11,000 years ago, following the broader human migration that had, over many previous thousands of years, spread people across nearly every habitable region of the world. The earliest Amazonian peoples were likely small, mobile groups, moving through the forest and along the rivers, gathering wild plants, fishing, and hunting the animals of the forest and floodplain, adapting their movements to the same seasonal rhythm of flood and retreat that we described in the previous part of our story. For a long stretch of the 20th century, many archaeologists and historians assumed that the Amazon rainforest, because of its generally poor soils away from the rivers, could never have supported large, complex, settled societies, and that the people living there must always have existed only in small, scattered, nomadic groups. This assumption has changed a great deal in recent decades, as archaeological research, using both traditional excavation and newer remote sensing technology, has revealed evidence of much larger and more complex human settlements than previously believed, particularly along the fertile Varzea floodplains bordering the main river and its larger tributaries. Along these floodplains, ancient communities took advantage of the same annual renewal of fertile soil that we described earlier, the same process that had shaped the flooded forest itself to support forms of settled agriculture. Researchers have found evidence of managed fields, constructed earthworks, and in some regions, deliberately modified soil known as terra preta, or dark earth, a type of unusually fertile soil created over centuries through the careful, repeated addition of charcoal, organic waste, and other materials by human communities. Terra preta remains, in many locations, noticeably more fertile than the surrounding natural soil even today, centuries after the communities that created it dispersed or declined. A quiet, lasting trace of a relationship between people and land that was far more intentional and long-term than was once believed. In certain regions of the basin, particularly in areas like the upper Xingu River region and parts of what is now the Bolivian Amazon, archaeologists have identified evidence of large, interconnected settlements, some organized around central plazas, connected to one another and to surrounding fields by networks of raised roads and canals. Some of these systems apparently supporting populations considerably larger than the small, scattered communities once assumed to represent the region's entire human history. It is worth saying gently that research in this area continues, and that population estimates for the per-contact Amazon remain a subject of ongoing scientific discussion, with some researchers proposing higher numbers than others, based on differing methods and differing sites studied. What seems increasingly clear across multiple independent lines of evidence is that the river and its floodplain supported a far richer and more complex human history than was assumed for much of the 20th century. The river itself served as the primary means of movement and connection across this vast landscape. In a region where dense forest made overland travel slow and difficult across long distances, canoes carved from single large tree trunks using tools, and in some regions, controlled fire to hollow out the wood, served as the essential technology of Amazonian life, used for fishing, for travel between settlements, for trade, and for the movement of people and goods along the river's many channels. Different communities developed their own particular canoe designs, suited to the particular stretch of river or type of water they most often traveled. Some built for the swift, narrow channels of upper tributaries, others built for the wide, open stretches of the main river itself. Fishing, unsurprisingly, formed a central part of life for many communities living along the river and its floodplain. And over many centuries, different groups developed a wide range of specialized techniques suited to the particular fish and particular waters they depended on. Some used woven traps set in narrow channels to catch fish moving with the current. Others used bows and arrows adapted for accuracy in and around water to catch larger fish near the surface. In certain regions, communities used the crushed bark or roots of particular plants, which had a mild, temporary stunning effect on fish in a contained area of water, allowing for controlled, sustainable harvesting without permanently damaging the local fish population. A technique requiring detailed, accumulated knowledge of local plant species and their effects. Beyond fishing, communities throughout the basin developed deep, detailed knowledge of the forest's plant life. Knowledge that has, in more recent centuries, become of considerable interest to outside researchers and scientists. Many communities identified and made use of hundreds of different plant species for food, medicine, construction material, and other purposes. Knowledge passed down carefully across generations through direct teaching and practiced experience, rather than through written record. Some of this knowledge, particularly regarding medicinal plants, has informed modern pharmaceutical research in later centuries, though it is worth noting, respectfully, that this knowledge originated with and continues to belong to the indigenous communities of the Amazon, developed over an immense span of time through careful, attentive observation of the forest around them. The linguistic diversity of the Amazon basin, even today, offers a quiet reflection of just how many distinct communities have called this region home over the centuries. Researchers have identified several hundred distinct indigenous languages historically spoken across the basin, grouped into a number of different language families that, in many cases, are not closely related to one another at all, suggesting that human settlement of the region occurred over a very long period of time by many different groups, developing largely independently across different parts of this enormous landscape. It is worth pausing here gently to consider the scale of what we are describing. Communities living along a river system covering roughly 7 million square kilometers, developing independently across many centuries, adapting to dramatically different local conditions, from the flooded Varzea forest near the main channel to the unflooded terra firma forest further inland, to the foothill regions where the Andes begin to rise. Each community developed its own particular relationship with its own particular stretch of forest and river, shaped by, and in turn gently shaping, the land around it, much as the river itself has shaped and been shaped by the land it moves through. In the part of our story that follows, we will look at how this long, complex human history along the river continued to unfold in later centuries as new arrivals came to the basin from across the Atlantic Ocean, bringing changes that would, in time, alter the relationship between people and river once again. For now, though, it is enough to simply picture the quiet continuity of that earlier history. Generations of communities moving along the water in canoes shaped by careful hands, tending fields renewed each year by the river's own seasonal flooding, and passing down, patiently, across centuries, an intimate and detailed knowledge of the forest and the water that sustained them. We continue our slow journey through the story of this river, moving now into the period when new arrivals from across the Atlantic Ocean first began to make contact with the communities who had lived along the Amazon for many thousands of years before them. In the early 16th century, European ships began arriving along the northern and eastern coasts of South America, part of a much broader wave of transatlantic exploration and colonization taking place across the Americas during this period. The first recorded European journey down the length of the Amazon River is generally attributed to a Spanish expedition led by Francisco de Orellana, which set out in the year 1541, departing from the Andean highlands with the original intention of finding valuable resources further east, before eventually finding itself carried largely by circumstance and by the current of the river itself, all the way down to the Atlantic coast, a journey of many months along a river system the expedition had not originally planned to travel in its entirety. It is from this expedition, according to most historical accounts, that the river received the name by which it is known today, inspired by an encounter, or perhaps a series of encounters, with indigenous warriors along the river, who Orellana's expedition compared, in their own accounts, to the Amazons of Greek mythology, a legendary group of warrior women. Historians continue to discuss, calmly and carefully, exactly how accurate or exaggerated these early accounts may have been, given that they were written by the expedition members themselves without independent confirmation, and given the tendency of many explorers of this era to draw comparisons to familiar mythology when describing unfamiliar people and places. What is clear is that the name persisted, applied first to the river, and eventually, in a broader sense, to the entire surrounding basin and forest. Following this early period of contact, the pace and nature of European presence in the Amazon basin developed slowly and unevenly over the following centuries, quite different in character from the more rapid colonization occurring in some other parts of the Americas during the same period. The dense forest, the difficulty of overland travel, and the sheer scale of the basin meant that European settlement, for a long time, remained largely concentrated along the main river channels and a limited number of larger tributaries, rather than spreading evenly across the vast interior. In this sense, the river continued to serve the same essential function it always had, as the primary route of movement and connection through a landscape that remained, away from the water, extremely difficult to cross. This period brought profound and often difficult changes for the indigenous communities who had lived along the river for so many generations before, including the introduction of diseases from across the Atlantic to which local populations had no prior exposure or immunity, and which spread, in many cases, well ahead of the explorers and settlers themselves, moving along the same river routes that had long connected different communities to one another. Historical demographic research suggests that these diseases had an enormous and lasting impact on indigenous population numbers across the Amazon basin in the centuries following contact, an impact whose full-scale researchers continue to study and better understand, drawing on archaeological, historical, and demographic evidence. We describe this history calmly and factually as one part of a much longer story, without dwelling on its more difficult details, though it remains an important and sobering part of understanding how the river's human history unfolded across these centuries. As the following centuries continued, the river remained central to the movement of goods, people, and eventually entire economic enterprises through the region. During the colonial period and continuing into the 19th century, various raw materials drawn from the forest itself became increasingly valuable to markets across the Atlantic. and the river served as the essential transportation route for moving these materials from the interior of the basin out to coastal ports, and from there onward to Europe and North America. One of the most significant of these economic periods centered on natural rubber, harvested from a tree native to the Amazon basin, whose sap could be processed into a material with a growing number of industrial applications during the second half of the 19th century, particularly following improvements in rubber processing technology developed elsewhere in the world. This period, often referred to as the rubber boom, brought a considerable wave of new settlement and economic activity to certain parts of the Amazon basin, particularly around cities like Manaus and Belém, which grew rapidly during this period as centers of the rubber trade, connected to the wider world by river and by the new port infrastructure built to support this growing export economy. The rubber boom brought considerable wealth to a relatively small number of traders, exporters, and rubber estate owners. Wealth that is still visible today in the surviving architecture of certain Amazonian cities from this period. At the same time, historical research has documented that the labor conditions imposed on many workers involved in rubber harvesting during this period, particularly in certain regions and under certain rubber estate systems, were extremely difficult, and in a number of well-documented instances involved serious and sustained mistreatment of indigenous and other laborers. We mention this history here factually and without dramatization as an important and difficult part of the broader story of the river's economic history, a period whose full details continue to be studied and reckoned with by historians of the region today. The rubber boom eventually declined in the early 20th century, following the successful transplantation of rubber tree seeds to plantations in Southeast Asia, where more efficient, organized cultivation gradually undercut the price and profitability of wild harvested Amazonian rubber. Following this decline, the pace of economic activity and outside settlement in much of the Amazon basin slowed considerably for a number of decades. Though the cities and infrastructure built during the boom period along the river remained. Throughout all of these centuries of changing economic activity, the fundamental role of the river as the primary route of transportation and connection across the basin remained essentially unchanged. Roads, where they existed at all, remained limited and difficult to maintain across much of the dense forest terrain. And it was not until the middle of the 20th century and the construction of new highway systems connecting the Amazon basin to other parts of Brazil and neighboring countries that overland transportation began to play a significantly larger role in the region's connectivity, a development we will return to gently in a later part of our story. For now, it is enough to picture the long, slow centuries during which the river remained, quite simply, the road, only reliable way to move people, goods, and ideas across this vast landscape, carrying explorers and traders, and in time, entire cities' worth of goods, down toward the Atlantic coast, the same patient current carrying all of it along, the way it always has, regardless of who or what happened to be moving upon it at any particular moment in time. In this part of our story, we turn away for a while from human history and look instead at something quieter and less visible, but no less important to understanding how this river has shaped the continent around it. The relationship between the Amazon forest and the very air that moves above it. It is easy to think of a river simply as a channel of water moving across the surface of the land, from higher ground to lower ground, eventually reaching the sea. This is certainly true of the Amazon, but it is not the whole picture. The forest that has grown up around this river system over millions of years does something else as well, something that scientists have come to understand more fully only in recent decades. It participates directly in the movement of water through the atmosphere above it, in a process sometimes described poetically, but also quite accurately, as flying rivers. Trees, as part of their normal biological function, draw water up from the soil through their roots and release a portion of that water back into the air through small openings in their leaves, in a process called transpiration. A single large tree in the Amazon rainforest can release a considerable volume of water vapor into the surrounding air over the course of a single day. Across the billions of trees that make up the Amazon forest, this collective release of water vapor is enormous, contributing a substantial share of the total moisture present in the air above the basin at any given time, alongside the moisture that evaporates directly from the surface of the rivers, lakes, and flooded forest we described earlier in our story. This moisture, released into the air by the forest itself, does not simply disappear, rises, cools, and condenses into clouds, and much of it eventually falls again as rain, sometimes over the very same stretch of forest that released it, and sometimes carried further by prevailing winds to fall as rain over an entirely different part of the basin, or even, in some cases, over regions well beyond the Amazon basin itself, including agricultural areas in other parts of South America that depend on this transported moisture as part of their own regional rainfall patterns. Researchers studying this process have described it as a kind of atmospheric river, an invisible but genuinely enormous flow of water vapor moving through the sky above the Amazon basin, driven largely by prevailing trade winds that move generally from east to west across this part of South America, carrying moisture inland from the Atlantic Ocean through repeated cycles of evaporation, transpiration, and rainfall across the forest until the moisture eventually reaches the base of the Andes Mountains far to the west. There, the rising terrain forces the moist air upward, where it cools further and releases much of its remaining moisture as rain, feeding, in a quiet, closing kind of symmetry, the very mountain streams we described at the very beginning of our story. The same high, cold waters that begin the whole cycle of the Amazon River all over again. This means that the forest and the river are not simply shaped by rainfall arriving from elsewhere. In a very real sense, over a large portion of the basin, the forest and the river are actively involved in creating a substantial share of their own rainfall, recycling the same water repeatedly as it moves across the basin from east to west, releasing it back into the air again and again before it eventually either falls at the base of the Andes or continues on, evaporating and returning to the atmosphere in a cycle that may repeat several times over the course of the moisture's journey across the continent. This self-reinforcing relationship between forest and rainfall has considerable significance for understanding how fragile or resilient the Amazon system may be to changes in forest cover, because a substantial portion of the rainfall across large parts of the basin depends on moisture recycled by the forest itself. Scientists have raised careful, ongoing questions about what might happen to regional rainfall patterns if significant portions of the forest were to be removed. Questions that remain the subject of continued climate and ecological research, involving considerable scientific complexity and some differences of view regarding exact thresholds and outcomes. We mention this gently as an area of ongoing scientific inquiry rather than as a settled conclusion, since research in this area continues to develop. Beyond its role in generating regional rainfall, the Amazon basin's forest and river system also plays a broader role in the wider climate patterns of the continent, and in certain respects, the planet as a whole. The sheer scale of evaporation and transpiration occurring across such an enormous forested area influences atmospheric circulation patterns well beyond the immediate boundaries of the basin. And the forest, through the long-term storage of carbon in its trees, soil, and other organic matter, plays a substantial role in the broader global carbon cycle, a role that scientists continue to study and refine their understanding of, particularly as forest conditions across the basin continue to change in various ways over time. It is worth returning here, near the close of this quieter, more atmospheric part of our story, to the image with which we began this documentary many segments ago. Cold water high in the Andes, beginning its long journey down toward the Atlantic Ocean. We can now understand that image a little more fully. That water, once it reaches the ocean, does not simply disappear from the story. A portion of it evaporates along the way, rises into the sky, drifts westward again on the trade winds, falls once more as rain somewhere across the basin, is drawn up again through the roots of a tree, released again into the air through a leaf, and continues, in this quiet, repeating way, to move through the system again and again, long before it ever completes its full journey out to the sea. In the part of our story that follows, we will turn our attention to the cities and communities living along the river today, and to the ways in which the relationship between people and river continues to evolve in the present moment. But for now, it is enough to simply picture that invisible river in the sky, moving quietly above the visible one, carrying moisture across the whole width of a continent, connecting mountain and forest and ocean in a slow, continuous, endlessly repeating cycle that has been turning gently for longer than any of us have been alive to notice it. We return now to the human story of the river, moving forward through time to look at the cities and communities that live alongside the Amazon and its tributaries today. In the present moment, continuing a relationship with the water that stretches back many thousands of years. As we discussed earlier in our journey, several major cities have grown up along the banks of the Amazon River and its larger tributaries over the past few centuries, each shaped in its own particular way by its location along the water. Manaus, located near the point where the dark waters of the Rio Negro meet the pale waters of the Solimoes, grew rapidly during the rubber boom period we described earlier, and remains today a large and busy city, a center of commerce and industry deep within the forest, connected to the rest of Brazil primarily by river and by air, since overland road connections to much of the rest of the country remain limited, even now, by the surrounding terrain. Further downstream, near the point where the river's many channels finally spread out into the wide estuary leading to the Atlantic Ocean, sits Belém, a city with its own long history along the water, serving for centuries as a key port, connecting goods and people moving along the river to ships crossing the ocean beyond. Between these two cities and beyond them, a great many smaller towns and communities dot the riverbanks, some accessible only by boat, their daily rhythms still closely tied to the seasonal rise and fall of the water, much as they have been for generations. Life in many of these riverside communities continues to reflect the long relationship between people and water that we traced earlier in our story. Homes in certain low-lying riverside areas are built on stilts or are constructed to float, rising and falling gently with the water level as the seasons change, a practical adaptation to a landscape where the difference between dry season and wet season can mean many meters of difference in water depth around a single dwelling. Transportation between communities in many parts of the basin still relies heavily on boats of various sizes, from small canoes, much like those used by earlier generations, to larger passenger and cargo vessels that travel longer distances along the main river channels, carrying people, food, and goods between towns and cities that may otherwise have no direct road connection to one another at all. Markets in river cities like Manaus and Belém reflect this ongoing relationship as well, with fish caught in the river and its tributaries, and fruit gathered from the surrounding forest, brought in by boat each morning to be sold in large, busy riverside markets. Much as similar goods have been brought to market by water for many generations before. Some of the fruits sold in these markets, including varieties that remain relatively unfamiliar outside the region, come specifically from the flooded Varzea forest we described earlier, harvested according to the same seasonal rhythm of flood and retreat that has shaped life along the river for so long. In the 20th century, the nature of connectivity across the Amazon basin began to change in a more significant way than it had for many centuries before. With the gradual construction of new highway systems intended to connect the Amazon region more directly to other parts of Brazil and neighboring countries, roads such as the Trans-Amazonian Highway, construction of which began in the early 1970s, represented a substantial undertaking, cutting through dense forest to create new overland routes, where previously the river and its tributaries had served as the only practical means of long-distance travel. These new roads brought considerable change to the basin, opening areas to new settlement, agriculture, and resource extraction that had previously been difficult to access by land. This period of increased overland connectivity has also been closely studied by researchers concerned with changes in forest cover across the basin. Since new roads have historically tended to open the way for new clearing of forest along their length and in surrounding areas, a pattern observed and studied extensively in this region and in forested regions elsewhere in the world facing similar patterns of road-linked land use change. We mention this here calmly as part of the ongoing, evolving story of the basin's human geography, rather than as a dramatic turning point. Since these changes, like the river's own changes, unfolded gradually over years and decades, rather than suddenly. At the same time, the river itself has remained central to the region's economy and infrastructure in the present day, even as road networks have expanded. A considerable share of goods moving into and out of the interior of the Amazon basin still travels by river, since, for many destinations, water transport remains more practical and in some cases considerably less costly than overland alternatives, particularly for heavy or bulk cargo moving between river ports. Large cargo vessels navigate the main channel of the Amazon and certain of its larger tributaries, much as smaller boats have always done, carrying agricultural products, manufactured goods, and other cargo along routes that, in their basic geography, have not changed since the river first settled into its current course many millions of years ago. The population living within the Amazon basin today includes an enormous range of different communities, from indigenous groups continuing traditions, and in some cases, languages that stretch back many centuries, to residents of large modern cities like Manaus, with populations in the millions, engaged in industry, commerce, education, and the full range of activities found in cities anywhere else in the world. Between these two ends of a very broad spectrum exist countless smaller riverside towns and rural communities, each with its own particular blend of traditional and modern ways of living alongside the water, a blend that continues to shift and evolve gradually, as it always has. It is worth noting gently that the relationship between the growing human population of the Amazon basin and the forest and river system that supports it remains, in the present day, an area of considerable ongoing attention among researchers, policymakers, and the communities living within the basin themselves, involving careful, complex questions about how economic development, conservation, and the rights and traditions of long-standing indigenous and local communities can be balanced going forward. These are significant and evolving questions, and it is not the purpose of our slow, quiet documentary tonight to resolve them, only to acknowledge calmly that they exist as part of the continuing story of this river and the people who live alongside it. In the part of our story that follows, our final segment, we will step back once more, gently, to take in the fuller shape of everything we have traced so far, from the rising of the Andes to the reversal of the river's flow, to the shaping of the floodplain forest, to the long human history along the water, to the invisible rivers moving through the sky above it all. For now, it is enough to picture the cities and towns along the water today, boats moving gently along the current in the evening light, markets filled with fish and fruit brought in from the river and the forest, and the same patient water continuing to move past all of it, the way it always has, toward the wide mouth of the river and the ocean beyond. As our story moves toward its close, we return gently to the wider view, the view we began with many segments ago, high in the cold air of the Andes Mountains, and we ask, quietly, what it actually means to say that a single river shaped an entire continent. We have traced, over the course of this documentary, a great many different ways in which the Amazon River has left its mark on the land and life around it. So it may be helpful now, in this slower, closing part of our story, to simply gather those threads together, calmly, one at a time, without hurry. The river shaped the physical land itself, first through the enormous geological processes that reversed its flow many millions of years ago, and then through the patient, continuous work of carrying sediment down from the young, rising Andes Mountains and depositing it across the vast, flat lowland basin, building, layer by layer, over millions of years, the very ground upon which the modern forest now grows. This process continues today, unnoticed by almost everyone, exactly as it has for millions of years before. Sediment moving steadily from mountain to floodplain to coast, continuing to build and rebuild the land gently, without pause. The river shaped the forest that grew up around it, creating, through its seasonal rise and fall, distinct ecosystems of flooded varzea, and agapo forest along its banks, and vast stretches of unflooded terra firma forest further inland, each supporting its own particular community of trees, fish, birds, and other creatures, all adapted over an immense span of evolutionary time to the particular rhythm of water that the river and its tributaries established across the basin. The river shaped the movement of water through the sky as well as across the land, as we discussed in the quieter, more atmospheric part of our story, with the forest itself grown up along the river's banks and across its basin, now playing an active role in generating a substantial share of its own rainfall, recycling moisture again and again as it moves slowly westward across the continent, connecting ocean and mountain in a repeating cycle that continues invisibly above us. At this very moment, the river shaped human history across the basin as well, serving first as the essential route along which the earliest peoples of the Amazon moved, fished, and eventually built complex, long-standing settlements supported by the fertile floodplain, soils the river itself created and renewed each year. Later, the river carried explorers, traders, and settlers from across the Atlantic Ocean into the heart of the continent, shaping centuries of economic and social history. Some of it prosperous, some of it, as we discussed honestly and gently earlier in our story, quite difficult. All of it unfolding along the same patient current that had already been flowing in one direction or another for many millions of years before any of it began. And the river continues to shape the present, carrying goods and people along its channel much as it always has, even as new roads and new technologies have gradually changed the balance of how people move across the basin, connecting cities and towns whose daily rhythms remain closely tied, even now, to the rise and fall of the water each season, exactly as they have been for as long as people have lived along this river. It is worth pausing here, near the close of our story, simply to sit with the scale of everything we have traced tonight. A river carrying, at its mouth, a greater volume of fresh water than any other river system on the planet. A basin covering roughly 7 million square kilometers, spread across parts of 8 different countries. A forest containing, by many scientific estimates, an extraordinary share of all the plant and animal species found anywhere on Earth. A diversity that continues to be studied, cataloged, and understood more fully with each passing year, with new species still being formally described by researchers on a regular basis. Even now, in the present day, a human history stretching back more than 11,000 years, encompassing an enormous diversity of languages, cultures, and ways of living alongside the water. None of this happened quickly. None of it happened according to any plan. It happened the way most truly large things in nature happen, through the patient accumulation of countless small, unremarkable moments, repeated across a span of time so long that it becomes, in a very real sense, easier to feel in the quiet of an evening than to fully hold in the mind all at once. The river we have followed tonight, from its cold, high beginnings in the Andes, down through cloud forest and foothill, out across the vast, flat lowland basin, through flooded forest and firm ground alike, past cities and towns both ancient and modern, and finally out to the wide, warm waters of the Atlantic Ocean, is still flowing at this very moment, exactly as it has been the entire time we have been telling this story. It does not pause for the telling of its own history. It simply continues, the way it always has, carrying water and sediment and fish and boats, and the quiet, accumulated weight of millions of years, steadily toward the sea. In the final part of our story, we will slow down even further, gathering the whole of this journey into a single, quiet, closing view, before letting the river continue on, as it always does, long after our own telling of its story has come to an end. We come now, gently, to the close of our story, though it should be said, quietly, that the river itself has no close at all. It simply continues, the way it has for millions of years, and the way it will continue long after tonight. If you have stayed with us this far, or if you are only now drifting in and out as sleep takes hold, there is nothing more you need to hold on to. We have followed a great deal of ground together tonight, from cold mountain streams high in the Andes, down through cloud forest and lowland, across a vast, flat basin shaped patiently over millions of years, through flooded forest and firm ground, alongside communities whose history with this water stretches back many thousands of years, and up into the quiet, invisible rivers of moisture moving through the sky above it all. None of it needs to be remembered in detail. It is enough simply to have let it move through you, slowly, the way the water itself moves. Picture, if you like, one final, quiet image to close out our journey tonight. It is evening, somewhere along the middle stretch of the river, far from any city, far from any road. The light is beginning to soften, the way it does at this hour, turning the wide surface of the water a gentle shade of gold and gray. Somewhere out on that water, a small boat moves slowly along, its passage barely disturbing the surface, headed toward a cluster of lights just visible in the distance, a small riverside settlement where the day's fishing will soon be brought ashore, and dinner will be prepared, much as it has been prepared along this river for longer than anyone can say. Along the banks, the forest rises up dark and full against the fading sky, the same forest whose trees have spent the day quietly releasing moisture into the air above them, moisture that will drift westward through the night, gathering slowly into cloud, and falling, perhaps tomorrow, perhaps the day after, as rain somewhere further along the basin, feeding some other stretch of forest, some other tributary, before eventually finding its way, once again, back into the great, patient current of the river itself, beneath the surface of the water, unseen in the fading light. Fish move quietly between the roots of trees, still standing in water from the wet season now beginning to recede. And further out, in the deeper channel, the main current continues on, exactly as it has for millions of years, carrying with it the fine, pale sediment worn down from mountains thousands of kilometers away. Sediment that will, eventually, help build new land somewhere along the coast, long after any of us watching tonight are gone. This is, in the end, simply what the river does. It moves, it carries, it shapes slowly and without hurry everything it touches. The mountains it drains, the forest it floods, the soil it deposits, the communities that have built their lives along its banks for thousands of years, and the very air above it, carrying moisture back across the continent in an endless, gentle cycle. It has been doing this for so long that it is genuinely difficult for any of us to hold the full span of that time in our minds, and there is no need to try. It is enough simply to know that it is happening right now, as you listen to these final words, exactly as it has been happening this entire time, and exactly as it will continue happening long after this telling of its story has ended. Tonight, we have followed only a small part of that immense story, moving slowly and gently through deep time, through geology, through forest, through human history, through the quiet science of rivers moving invisibly through the sky. There was never any need to rush through any of it, because the river itself has never rushed. It simply continues, patiently, the way water always does when it is given enough time, shaping a mountain range into a river system, shaping a river system into a forest, shaping a forest into a home for an extraordinary diversity of life, human and otherwise. All of it connected quietly by the same slow, continuous flow of water. If you are still listening, you can let go now of any need to follow the story further. There is nothing more to track, nothing more to remember, nothing waiting around the next bend that requires your attention. The river will still be there, flowing the same patient way whenever you wake. The forest will still be breathing its slow, seasonal rhythm of flood and retreat. The cities and towns along the water will still be going about their quiet evening routines, boats still moving gently along the current, lights still glowing softly along the darkened banks. You can rest now. There is nothing left to hold on to. Only the sound, if you are imagining it, of water moving slowly past, the way it has moved for millions of years, carrying a continent's worth of quiet, patient history along with it, out toward an ocean that has been waiting patiently this entire time for the river to arrive, exactly as it always eventually does. Good night.